So now we're going to have a look at different kinds of oscillators. So we've seen the square oscillator that goes like, that's a digital oscillator, meaning it's binary. It's either 0 or 1, 0 or 1, 0 or 1. So an oscillator is something that it's a signal that always repeats itself through time. So our square oscillator, as we recall, is defined by essentially by two parameters. The first one being the period, which is like the cycle at which after which the oscillator will repeat itself, and the other parameter is called the duty cycle. Now there's other kinds of oscillators that are included in Plaquette, and these other oscillators, however, are not digital or binary oscillators. They are a floating point or continuous oscillators. So they actually generate values between 0 and 1. So one of them is called the sine oscillator, and this one generates a sine wave. So it goes a bit like this, and again it has a period. It is defined by a certain period at which the cycle repeats itself. If we want to create a sine oscillator, it's very easy. What we'll do is we'll simply use the sine OSC object. This one does not have a duty cycle because it's a bit different in that sense. There's like just the movement of the curves does not really allow for a duty cycle. It doesn't really make sense. So it's just the period, and by changing the period, you can update the speed at which the wave is repeating itself. Another kind of generator oscillator that we can use is called the triangle oscillator, and this one goes like a triangle. So it goes up and down and up and down in a linear fashion. And again, we have this period that we can change. So you can create a triangle oscillator by using the tri-OSC. And of course, like here, I should probably rename that because it's no more a square. I'll just write oscillator. And here, I'll send this oscillator value to, for example, in this case, a serial port. And using the serial plotter, you'll be able to see in real time like the signal that is being generated. So the triangle oscillator is a bit similar in a sense to the square oscillator because there's a way to control sort of the tilt of the triangle by using a parameter called width. And the width is expressed as a percentage, and by default it's 0.5, so you get this sort of this kind of perfect triangle that just it takes as much time to go up as it has to go down. But by changing the width, so the width represents the tipping point as part of the period. So for example, if you use a width of 0, you'll have something shaped a bit like this. And if you use a width of 1, it will be the opposite. So you can try to change that, and here you can change that width by calling OSC.width. Of course, this is not going to work if you have a square oscillator. It's not going to work if you have a sine oscillator. It's just going to work for the tri oscillator. So OSC.width, I don't know, I can try 0.2, and you can try out different values. So you should try to, as an exercise, to change to use these different oscillator, the square oscillator, which comes with a period and the duty cycle, the sine oscillator, which just comes with a period argument, and finally the tri oscillator, which comes with both a period and a width argument. And by sending them to the serial with using that code, you should be able to just see what the wave looks like.